So now we've got an idea of what a function and a function machine is. Let's have a look at what it is to have a composite function. Now, continuing with the idea of function machines, let's pretend that we've got one of these function machines over here, and it's got an input here, it's got an output there, and what this function machine is going to do is it's going to multiply the input by 2, and then it's going to plus 1. Alright, and that there is now created a function that we can put some kind of input in, and the function machine will multiply the input by 2 and then add 1. But instead of just stopping there, we put this function into another function machine. And in this function machine, it's going to perform something else and have another output. So let's say, for example, that this function machine squares the input and then adds 2, multiply the input. So now what we have is a function machine that does its job and then spits the output directly into another function machine. And that in essence is what a composite function is. You take one function, you perform that function, and then with its output, you put it directly into another function, perform that function, and then we'll spit a final output. Now for the purpose of this, because we've got two different function machines, we're going to need to label them. So I'm going to call this function machine F and function machine G. So now what we've got here is when I put my input in, let's say I put in X, what it's first going to do is it's going to perform the F of X, and then that'll spit out an output. And then this machine will then do the G of the F of X. So it's going to perform its own function on the F of X and then spit out an output. And we call this output the G of F of X. Now, if we've got such a problem, what we need to do is we need to just break it up step by step. So let's find this G of F of X. Now we can rewrite this G of F of X to say that we're wanting to find the G of the F of X. So first of all, we need to find what the F of X would actually be. So this output just in here is going to take our input of X, it's going to multiply the input by 2, so it'll be 2 multiplied by X, and then it's going to add 1. So what we're essentially going to substitute into the G machine is 2x plus 1. So since the F of X equals 2x plus 1, we substitute this 2x plus 1 into here, and we're finding the G of 2x plus 1. So now what we're left with is, what is the G of X? Well, let's actually simplify this for a little bit. Let's just have our G of X machine here. So our G machine, which is going to do the same thing as it's doing up here. But in the input, let's just have a look what it's going to output if we input X. So first of all, it's going to square the input, so that'll be X squared. And then it's going to add 2 multiply the input. So it's going to add 2 multiplied by X. So we know that the G of X is equal to X squared add 2X. So now what we can do is we can substitute this function just in here into the function of G of X. So as we do that, that'll be our input squared, so this will be the 2x plus 1 all squared, and then add 2 multiplied by input, so plus 2 multiplied by input of 2x plus 1. So now we've left with just an expansion problem. So if I expand this first section first, so because it's a perfect square, 2x times 2x will be 4x squared. Then multiply these two will be 2x, double it will be 4x, so plus 4x. Then 1 times 1 is 1, so we plus 1. Then I've got to multiply this one out by 2. So 2 times 2x will be 4x. 2 times 1 will be 2. And from here, if I collect my like terms, there's no other x squareds. There's 2 x's, so that'll be 8x. Then 1 plus 2 is 3. So therefore, my final output of the g of 2x plus 1 is equal to 4x squared plus 8x plus 3. So to summarise, the general idea behind composite functions is you've got one function's output being put directly into another function. And we call that the, in this case, we're having the function of f being put into the function of g. So we call this the g of f of our original input of x. Now, original input's not always x, and we might explore that in a future video.